Okay, in this video, we are going to be using the chain rule to find the partial derivatives indicated, and we're going to write them in terms of the independent variables, which is kind of the most annoying step, but let's see what the problems look like. So this is number 5 from assignment 2 if you're in my class. G of xy is cosine of x minus y, and x is equal to 3u minus 5v, y is equal to negative 7u plus 15v. All right, so that means that we have g, and g is a function of x and of y. And then x is a function of u and v, and y is also a function of u and v. So I always draw these dependency diagrams because they really help me out to make sure that I'm getting the partial derivative correct. We are looking in this case for partial g, partial u, so partial u, which means all our paths must lead to u, which means we're going to go g is a function of x is a function of u, g is a function of y is a function of u. So those are the paths that we're going to follow. So we will have partial g partial x times partial x partial u plus partial g partial y times partial y partial u. Now we just have to calculate all these things. So partial u, we need partial g partial x. The derivative of cosine of something is negative sine of that thing. The derivative with respect to x of x minus y is 1, so we just get negative sine of x minus y. Now we need to find partial x partial u, which is going to be from here. That's definitely just 3. Plus partial g partial y, the derivative of cosine of something is negative sine of that thing. The derivative of x minus y with respect to y is negative 1, so we get negative sine, so positive sine of x minus y, and then times partial y partial u. So here we have y is negative 7u plus 15v, partial u is negative 7. And so we're not done because we want our answer in terms of the independent variables, so we really need to figure out what x minus y is. So x and y are these, so x minus y is going to be 3u minus negative 7u is 10u, and then negative 5v minus 15v is negative 20v. So x minus y is 10u minus 20v. So we have negative 3 sine of blah and negative 7 sine of blah, which means we have overall negative 10 sine of blah, where blah is 10u minus 20v. And that's it. That is partial u for this function. Let's take a look at the next one. Oh no, I guess we're doing partial v also. So partial g, partial v, I thought we were like done with that problem, but we weren't, which maybe is better because we set up all this stuff, so we might as well use it. All right, so we got to follow the paths that lead to v. So we go x to v and then y to v. All right, and then we'll write our partial derivative, so it's going to be partial x, so partial g, partial x, and then partial x partial v, plus partial g partial y times partial y partial v. Okay, now we're calculating all these things again. So partial g partial x is still just negative sine of x minus y. So like a lot of the work ends up very similar if you're doing partial u and then partial v, because the partials of g, like with respect to x and v, don't change. But then partial x partial v up here is negative 5 plus partial g partial y, so that again is going to be negative cosine of x minus y times negative 1. It's going to be negative sine of x minus y times negative 1, so that gives us sine of x minus y. And then partial y partial v up here is 15. All right, and then we do the same thing. We need to collect. So I actually think I'm getting this wrong. I think we need, oh no, wait, hold on. Yeah, so we're going to get 20 sine of x minus y, we said is 10u minus 20v. So 10u minus 20v. So that's partial g partial v. So we found both possible partial derivatives. All right, let's look at another problem where I think we only have to do one this time. I was fooled last time. This is number 10. We have f of xyz is xy minus z squared. X is r cosine, which feels kind of polar, but then y is equal to cosine squared of theta, so not really. And then z is equal to r. All right, so what does our dependency diagram look like? F is a function of x, y, and z. So we put all those branches in. X is a function of r and of theta. Y is a function of just theta. There's no r, which means that partial y, partial r would be 0. And then z is not a function of theta at all. It is only a function of r, which means partial z, partial theta would be 0. Okay, because of this, we're looking for partial f, partial theta. Follow the branches that lead to theta. So we go to x to theta, y to theta. Z does not go to theta, so it's not going to contribute anything to this partial derivative. All right, let's write it down. So we would have partial f, partial x times partial x, partial theta, partial f, plus partial f, partial y, partial theta. And then if it happens, so I'm going to include it just as a generality here, we would have partial f, partial z, and then partial z, partial theta. But that we know is 0. So this is overall the partial derivative with respect to theta. Now we just got to fill everything in. So here goes. Partial f, partial x. Look at f of x, y, z. Partial x is just y. Negative z squared does not have any x's in it, so we just get y. And then we need partial x, partial theta. So the derivative of r times cosine of theta is going to be negative r sine of theta, because we're taking the derivative with respect to theta. Plus partial f, partial y. So xy is going to give us x, and negative z squared gives us nothing. So we just get x. Partial y, partial theta. So we're looking here. That's going to give us 2 cosine of theta times negative sine of theta. So negative 2 sine cosine, or negative 2 cosine sine. Or negative sine of 2 theta if you want, but don't do that because I didn't do that. I mean, you could do that. It's a good move. I'm not doing it because I don't think it really helps in this problem. And then if we were to go on, we would need partial f, partial z, which is negative 2z, times partial z, partial theta, but that's just 0 because there's no theta in z, so when you take the derivative with respect to theta, it's like you're just taking the derivative of a constant, so times 0. All right, so then we want this whole thing in terms of r, theta, r and theta. R and theta are the independent variables. All right, so partial f, partial theta. Y is equal to cosine squared. So we're going to get negative r sine theta cosine squared of theta. X is equal to r cosine. So we're going to get r cosine times negative 2 cosine sine. So we're going to get negative 2r cosine squared sine. And then you get nothing from the negative 2z times 0, obviously. And if we combine, these are actually like terms. So we're going to get partial f, partial theta is negative 3r sine theta cosine squared of theta. All right, we got one more problem in this assignment. So let's see if we can do it. Number 13. G of xy is 1 over x plus y squared. X is equal to r cosine theta, y is equal to r sine theta, and r theta, so the ordered pair, I guess, is going to be 2 root 2 comma pi over 4. We want to find partial g partial theta at the given point. So dependency diagram. G depends on x and y. X depends on r and theta, and so does y. And we are looking for partial g partial theta. So that means we follow all the paths that lead to theta, so to x to theta, to y to theta. All right, and we can write it down. So partial g partial x partial theta, plus partial g partial y, and then partial y partial theta. Okay, now we got to just calculate stuff. So partial g partial theta is going to be the derivative of 1 over x plus y squared with respect to x. So that's like x plus y squared to the negative first is going to be negative x plus y squared to the negative second times 1 because x is the variable. So I'm going to write that as negative 1 over quantity x plus y squared squared. Partial x partial theta is going to be, we're up here, is going to be negative r sine of theta. Plus partial g partial y, so again it's x plus y squared to the negative first, is going to give you negative x plus y squared to the negative second times 2y. So I'm going to write that as negative 2y over x plus y squared squared. Then we need the derivative of y with respect to theta, which is going to be just r cosine theta. So this problem's a little bit different. I don't need to get it down to the independent variables. I just need to substitute. I know that I'm going to substitute 2 root 2 for r and pi over 4 for theta. What I also want to do is figure out what x and y are. So I'm going to go up and substitute it and get actual values for x and y before I do this. So x is r times cosine theta, so it's 2 root 2 cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. So simplify that and we just get 2. And then y is a similar story, 2 root 2. The sine of pi over 4 is also root 2 over 2. So we actually just get the ordered pair root 2, 2. Or x is 2, y is 2. It's not really an ordered pair. I mean, it is, but what would I be doing with it? So I'm going to substitute in here negative 1 over. So when you do y squared is 4, x plus y squared is 6, so 6 squared. And then you're doing negative, it's actually just negative y, but negative r times sine of theta. Plus, you're going to get negative 4 over the same 6 squared. And then it's really just the x value, r times cosine of theta, but you can directly sub like this. And so this cleans up to just 2 over 36, and then minus 8 over 36, which is negative 6 over 36. I don't know why I'm struggling with this, which is negative 1/6. All right, that's actually this entire assignment, so I hope this was helpful, and good luck.